Hello everyone, welcome to another quick episode of servo motion control. So in this video we will try to see the different modes of servo control. There can be a servo access used with PLC or without PLC, so we will try to deep down into all the possible modes. The first one is IO terminals using the digital inputs, digital outputs, or maybe the analog inputs, analog outputs. So in this way we can use potentiometer or some other digital inputs or maybe push buttons or switches to use a servo access. So this is totally discrete control, no synchronization, no commands from the PLCs are here. So it's generally used in the applications which can be fulfilled with BFD also, but we wanted high-end torque and certain requirements on the application side that is why we are using servo access. The second mode is internal positioning. In the internal positioning mode, we are using internal positioning registers in the servo. So in that case, what we are doing, we are already putting the commands or the commanded position values inside the registers in servo drive. And then using the analog inputs, digital inputs, we are feeding the set point or the command to the servo, and then based on that internal settings, servo is doing the positioning. And the third one is pulse train output. So in pulse train output, we are using digital outputs from the controller. When I say controller means PLC. These are the fast outputs and we use fast inputs on the servo. Generally controller are providing 100 kilohertz and 200 kilohertz pulses for the servo operations. And the fourth one is generic drive interface. When we say generic drive interface, in this way we are sending all these commands over Modbus or maybe some other communication protocol which is not very fast. We are simply sending the commands. Maybe we are asking drive to go to home position, to have some absolute movement, to have some relative movement, but from the controller it is only the command, not the set point. When I say set point, I mean the motion control set point. And the fifth one is motion control over communication. The best example is Canmotion, Ethercat, Ethernet, Profinet, Sercos. So in this way or in this method, we are calculating the set point inside the controller, and in each cycle we are sending this set point to servo. So the difference in generic drive interface and motion control over communication is, in generic drive interface we are simply sending the commands, but in case of motion control over communication, this error handling is done inside the, or you can say the position control loop is inside the PLC or the motion controller. Yeah, this is a very quick and crisp video on the control modes. Let us know if you need more details on this. Thank you everyone.